So we are discussing a topic that is called as kinematic graphs. Actually what happens is there is a branch of physics, like there are many branches, sound, light, then there is this branch called as mechanics, there is modern physics, there is nuclear physics, there are many branches of physics, out of which one branch is called as mechanics. Mechanics deals with motion and it deals with force, or all the existences. All Newton's laws come in this. The mechanics can further be divided into two components. One is called as statics. This is when the objects are stationary, not moving. This is statics. And the second is dynamics. And this branch of dynamics will further be divided into two parts. One is called as kinematics and the second is kinetics. If you do not consider the mass of an object and you only see the motion, you see the velocity, you see the acceleration, you see the time taken, displacement, distance, speed, all of these together is in kinetics. And in kinetics, you get all velocity, acceleration, everything together with mass. So you have force, you have momentum, you have kinetic energy, potential energy, all of that will be discussed in kinetics. We are not discussing kinetics, we are discussing kinematics. This is kinematic graph. Why is this connected to mathematics? Physics is that branch of science which uses the tools or the insight given by mathematics to the best possible extent. And that is why physics is given rise to many branches of engineering, many branches of many other fields as well. We are discussing one such branch that physics has, in which the tools and the power of mathematics is used to the best possible potential. And that is kinematic graph. Let's see what is there. Let's see the first graph. The first graph is distance time graph. And let's see this graph. On y-axis there is distance traveled, on x-axis there is time. And you see the graph is increasing first uniformly, then it remains constant, and then it increases further uniformly again. Key points are here up to this point. So from t is equal to 0 to t is equal to 4, that is in 4 minutes, the unit is minutes. In 4 minutes, the distance travelled is 1 kilometer. So whatever be the vehicle that you are using, may it be a cycle, may it be a car, may it be a two-wheeler, you are going 1 kilometer in 4 minutes. After that, next 2 full minutes, you are right there, stationary, not moving at all. After that, from here, t is equal to 6 to t is equal to 16, 10 minutes. You go from 1 kilometer to 8 kilometers. So 7 kilometers in 10 minutes. This entire information is depicted. So t is equal to 0, your distance was 0. T is equal to 4, your distance was 1 kilometer. T is equal to 6, distance is still 1 kilometer because you remain stationary in these 2 minutes. And t is equal to 16, you reached 8 kilometer distance. So this entire information is depicted in this graph. From this graph, we can conclude or we can deduce a lot of things. A lot of information can be found by this. What is that information? First is this. From using this information, I can calculate what will be the speed in the first 4 minutes. So it is traveling 1 kilometer in 4 minutes. So the speed is 0.25 kilometer per minute. In the second part of the journey, the distance is same 1 kilometer to 1 kilometer, so it is not moving at all. So the distance is 0 divided by 2 minutes. So this speed is 0 here. And then we get the speed from 1 to 8, that is 7 kilometers, in time 6 to 16, that is 10 minutes. So this is 0.7 kilometer per minute. Now if you compare, the first speed is 0.25, the second speed is much higher. And you can see this line, although it is inclined to x-axis, but the inclination is less. So this is not flat line, but it is more flat than vertical. But here the line has gone a lot vertical, not vertical, but a lot towards the vertical axis, towards the y-axis. We call this as the inclination. If this angle is more, then you get this value to be there. Here, if you check, this angle is lot more than this angle. So this value is more. Otherwise, if the rate or the speed was same in both the cases, this graph would have been parallel to this line. It is not parallel. So if it is inclined more, then the speed will be more. If this was inclined lesser, the speed would have come lesser. All this information can be deduced from this graph. If you have a distance time graph, from distance time graph you can find out the different speeds of motion, and of course you can find the average speed. What is the average speed? Total time is 16 minutes and total distance is 8 kilometers. So 8 kilometers upon 16 minutes will be 8 by 16, 1 by 2, 0.5 kilometers per minute. That will be the average speed of this motion. All this information can be deduced from just one distance time graph. This is what we study in kinematic graph. Let's see the next example. Ashraf's school is 4 kilometers from his home and it takes 40 minutes to walk to the school. One morning he leaves at 7 a.m. and 15 minutes later he realizes that he has left his boots at home. So he is going to the school in the school shoes, but then for some occasion, there must be some kind of event, so he requires his boots as well. So he forgot that, so he went back. He runs back in 10 minutes. It takes him 3 minutes to find the boots. He then runs to the school at constant speed. This graph is shown. The graph is showing his journey. So at 7 he starts, 15 minutes he walks and he reaches, he's forgotten something. Immediately he runs back. He is not taking 15 minutes to reach back. He is taking only 10 minutes to reach back because he is running. He reaches there, 3 minutes are spent here to find the boots. And then he runs at a constant speed. This, if the speed was not constant, this curve would have been something like this. Or something like this. But because this speed is constant, the graph is showing a straight line here. And the boy has reached the school here. Now let's see, we'll answer this question based on this. Let's see. How far has he walked before he remembered his boots? He has walked 1.5 kilometers. Then what happens to the graph as he returns home? The graph is a flat line and it is not just parallel to x-axis, it is on the x-axis, saying that this entire distance is from home. Because he went back home, the distance from home is 0. It is literally on x-axis. The graph is literally on x-axis here. What does the horizontal line on the graph represent? The horizontal line on the graph represents the time. The time starting from 7 till the time he reaches the school. I am only assuming that he should be reaching the school at 8 and he reaches at least 6-7 minutes prior. But for that he has to run. From here he runs back home, finds the shoes and he runs to the school again. So there is a lot of running that he had to do because he forgot something. Next, how fast did he run in meter per minute to get back home? Now see this is 1.5 kilometers. So we write meter 1.5 kilometers is 1500 meters. Upon how many minutes? It took 10 minutes to run back. So this is 150 meter per minute of run. So this boy is running back at a speed of 150 meter per minute. Next, is there any question? No, these are the answers. Yeah. The distance time graph represents Monica's journey from home to the library and back again. So the girl started at 9, she went to the library. Presumably she sat there and studied something and then she goes back home. Or maybe she had just gone there to exchange the books because it doesn't seem to be time long enough to study. But in whichever case, She's exchanged her books and she's coming back. How far was Monica's home at How far was Monica from home at 906? Let's see where is 906. This is 905, this is 906. So she was here and this is 400, 600, 660 meters away. 660. This is from 400 to 800 is 200 and there are 10 difference. So each division is 20. So you just count and we get 660 here. How many minutes did she spend at the library? She spent, I think, from here to here. So this is 10, 15, 16, 17, 7 minutes. She spent 7 minutes at the library. At what time was Monica 800 meters away from her home? Now this is very interesting. She was 800 meters away twice. While going back, she was at one point she was 800 meters away, and while returning from the library, again came a point when she was 800 meters away. So what do? At 800 meters, draw a flat line, and wherever it intersects, from there draw a line, and we'll get this. So at what times? There is this word time, not time, it is times, because there are two times. So once was this, second was this. You draw the straight lines precisely, you get the exact time for this. On which part of the journey did Monica travel faster? Going to the library or returning back? See, the distances are same. If you see the graph, the distance of library from her house is not changing, it is 1200 meters. But what is changing is the time. So here she took only 10 minutes. While here she has taken a lot more time. So without calculation I can tell that the distance is same. So minimum time means maximum velocity, maximum speed. So the speed in the first case, going to the library was faster. Coming back from the library was lesser. Maybe she got tired walking in the sun. Whatever be the reason, but returning back took more time. Maybe she met a friend at the library. She's returning with the friend and they're just chatting, so that slows down sometimes. Let's see the next one. Omar left school at 16:30. That's here. On his way home, he stopped at a friend's house. So he's reached the friend's house here, stopped for a length of time. Before going home on his bicycle, and then he went back home on his bicycle. The graph is showing this information. Now let's see the questions on this. How long did he stay at his friend's house? From here to here. Check the time. We're not going to answer this now, it's very simple. At what time did he arrive home? Yeah, it's very simple. Omar's brother left school at 16:45 and he walked home using the same route as Omar. If he walked at 4 km per hour, work out at what time the brother passed Omar's friend's house. So what you have to do is 4 km per hour. So we are starting from here, and from here, in 1 hour these 4 kilometers will be completely finished. So here, in 1 hour, the brother would reach home. So you just draw the graph like this. And wherever this line is intersected, this is where he is passing the house. May not be as I am showing here. It may be, with the correct drawing, you might realize either line is passing slightly before or slightly after this point, wherever it is. But just work it out and then just take that time and then tell me whenever they are passing. Yeah, question number 3, question number 4 is something that you should solve now. We'll talk about the speed in distance time graph. Speed is equal to distance traveled divided by the time taken. So whatever is the distance that we are showing divided by the corresponding time will give us the speed. We have seen in the first graph, we have seen 3 different speeds. Even in the Oman speeds, we have seen different speeds. So let's see. Let's see some numericals based on this. Yeah, this is good exercise. Clearly describe what is happening in each of the distance time graphs below. Suggest a possible real life situation that would produce each graph. So we are asked two things. First, we have to describe the graph properly. And second, we have to tell in what kind of real life situation would this kind of graph be actually observed. So let's see, this is straight line graph between distance and time. It means that distance and time are proportional to each other, which means that distance upon time must be constant. And if distance upon time is constant, that is when the graph comes out to be a straight line, because the speed is always constant in that case. Distance upon time is speed. And if the speed is constant, you get this kind of a graph, when the graph is a straight line inclined to x-axis. So this kind of graph is obtained. That is possible when we will describe this graph as this graph shows the distance traveled by a vehicle or by a man or by an object against time when the speed of the vehicle is constant. And the example of that is any on a flat road, in a completely free road, no traffic, no signals, and you're traveling, and you're trying to travel with the constant speed. That is when you get this kind of a graph. The most important observation about this graph is increase in distance is same when the increase in time is also same. So in 1 minute here, you travel this much distance. In 1 minute here, you will again travel the same kind of distance. Distance in increment in distance upon increment in time is same for all values. This is when we say the speed is uniform. So this is a graph of uniform speed or uniform velocity. Let's see this graph, second graph, the distance is constant. That means the object is kept arrived here and this point is here. Distance between us is 1 meter. This 1 meter is maintained throughout. I am not moving, that is not moving. This is when we say the object is at rest or it is stationary. If it is not moving, it is not moving. The time is going on, but the object is not moving, so the distance remains as it is. Here, the object is going at a certain speed, and then it immediately, or not immediately, a very small amount of time comes back. So let's say we are walking like this, very slowly, and somebody screams and I'm like completely back. This kind of motion is depicted here. You are climbing vertically, slowly, making sure you don't fall. Something happens, you lose your grip, you fall down. The falling is very quick. So you're back to zero distance from ground. So here you're going, you reach a point, you stop there, then you walk again and you reach the next point, you stop there. It can be more vertical motion as well. You climb the first ladder, you reach the first floor, you wait there, then you take the next step, stairs or ladder, go to the second floor, wait there. Or it doesn't, because the graph is shown to be going upward, doesn't mean you're walking upwards. You might be walking horizontally, you come here, you wait. You stay here for some time, then you walk here, then you step, then you stop here for some time. This is depicted in the graph. Next. This is distance time diagram in which the first is the velocity increases. The distance increases, that means the speed is constant. Then suddenly the distance is increasing when there is very small increase in time. From here to here, time is increasing very narrow, but the distance is increasing very rapidly. So that happens when you're going very slowly. Suddenly there is a free space in the road, you accelerate very quickly, you cover a lot of distance. Again there is rapid, you slow down. That's the kind of graph. Here the graph is showing from one point you're coming back. So supposedly I'm saying I'll measure from here and I was initially here. So from here I come back. So my distance from this point initially was 2 meters. Now it is 1.9, 1.8, 1, 0.9, 0.8, 0. Eventually the distance is 0. Then I start walking in the opposite direction again, and the distance increases. Initially the distance was decreasing, now the distance is increasing. The graph shows Anjali's daily run. How fast, for how many minutes does Anjali run before taking a rest? For 5 minutes, 6 minutes. Here she stops. So that is 6 minutes. 1, 2, 3, 4, 5. 6 minutes is the time when she stops. So she is running for 6 minutes, then she stops. Calculate the speed in kilometer per hour at which Anjali runs before taking a rest. So this distance is 1 kilometer. Divided by this is 6 minutes. 6 minutes is, we want to convert this in hours. So 6 upon 60. So you divide by anything, that means you multiply by the reciprocal. So you will get 1 into 60 upon 6, which is equal to 10 km per hour. This is the speed with which Anjali was running before she stopped, before she paused. How many minutes does she rest? She rests for 3 minutes, I think, from 6 to 9. She is resting for 3 minutes. Calculate the speed in meter per second at which Anjali runs back. So from 1 kilometer, she comes back to original speed. So again the distance traveled is 1 kilometer, but this time we will write 1000 meter because we have to find it meter per second. And the time taken is 9 to 10 to 14. So 5 minutes. 5 minutes is 300 seconds. So we will get rid of the zeros and we will get this is 10 by 3. So this is 3.33 meter per second. That's how we can calculate this. Next question. Question number 3. Let's just go on. 3, I think we should do 4, we should do as well. 5 as well. Now we'll move to the next topic, and that is speed time graph. We have yet seen only distance time graph. We'll now see speed time graph, which means that your time is increasing and with time your speed is also changing. So you can write V or you can write speed, and this speed is also changing. Like in this graph, initially the speed was increasing, that is you are accelerating your vehicle, the motion is such that your speed is increasing from 0 to a certain level, that is let's say 18 or 19 or whatever it is, meter per second. Then it stops. The car is not stopping, the vehicle is not stopping. The increase in speed is stopping. There is a stoppage to the increase in speed. There is a stoppage to the acceleration, and the speed is constant. And now after this you apply the brakes and the car or the bike slows down and it eventually stops. This is when actually the speed becomes 0, and when the speed becomes 0 the vehicle has stopped. This is speed constant, it is not stopping. Initially when the distance time graph was like this was distance and this is time. If the graph is like this, it means the object has stopped. But if velocity or speed time graph is like this, it means this is not stopping. This is uniform speed. The speed is constant. The position is not constant. The speed is constant. So this is what is interpreted from here. Now let's see if there are any questions based on this. Yeah. The speed time graph represents the motion of a particle over the period of 5 seconds. From O to A to B, B to C, C to D, over the 5 seconds. During which periods of time was the particle accelerating? Accelerating is the speed being not constant. The speed must be increasing or changing. The speed is changing from O to A. So this is the first point. Second is from B to C. It is also changing. So during which periods? 0 to I think 0.8 seconds. Then from 2 seconds to 3.5 seconds. These are the time periods when the speed of the particle is changing. That means the acceleration is happening. Calculate the particle's acceleration 3 seconds after the start. So after 3 seconds, the speed is 22 or 23. I am taking 22. You know the exact value by drawing the correct straight lines. I am taking 22 meter per second minus initial speed was 0 divided by change of time is 3 seconds. So this is equal to 22 upon 3, which is equal to 7.33 meter per second square. That is the value of acceleration. And C, calculate the distance travelled by the particle in 5 seconds. This is very interesting. Distance travelled in 5 seconds. The speed time graph can give us distance as well. How? Now you just complete the graph from here to here. If you want to find out the total distance, find the total area under this graph towards up to x-axis. So this entire area will give us the distance travelled. Somebody says, sir, area, how can it be in meters distance travelled? Because this speed is in meter per second. So this into time in seconds, second gets cancelled. The answer is in meters. We can just calculate this here. This is the area of this first triangle, second rectangle. This can be taken as a rectangle, this can be taken as a triangle, and this is a rectangle as well. And just add the areas, you will get the answer. You can take this entire thing as a trapezium as well and then calculate the area as well. It is also fine. Next question. The diagram shows distance time graph for a short cargo. The greatest speed is reached is 60 km per hour. The distance is 2 km. The greatest speed is 6 km per hour. This is not the speed, this is the greatest distance. Greatest speed is when this graph has the highest inclination. Initially it is starting flat, so the speed is initially 0. Then slowly the speed increases. This is when the speed is maximum, then the speed comes slow. Here it might stop again. The acceleration in the first 2 minutes and the deceleration in the last 2 minutes are constant. So in the first 2 minutes the acceleration is taking place. Here the speed is maximum. From here the speed is slowing down. You think that the object is going up. No, the distance is increasing. When you apply the brakes, you still move ahead, right? So the distance is increasing. But the increasing distance is slowing down. It is now becoming, the curve is becoming flatter. So in this case, the brakes are applied. In this case, the accelerator pedal was applicable. Can draw the speed time graph of the journey. Yeah, you can draw the speed time graph here. The speed can be calculated. Let's see the answer of this. This is the speed time graph. How do you know that? See this. Initially, the graph is showing. The graph is showing. This is where the distance is increasing because the speed is increasing. So initially you travel less because the speed is like, if the speed is 1 meter per second, so in 1 second you travel only 1 meter. But if the speed becomes 1.5 meter per second, so in the next second you travel 1.5 meter. So the distance traveled in the same amount of time is increasing. Here it is decreasing. So from here to here there was acceleration. From here to here there is deceleration. So that's what is being shown. The speed is increasing initially because of acceleration. Here the maximum speed is reached and suddenly the brakes are applied and the speed is slowing down. It is given that the acceleration and deceleration are equal in magnitude. So this and this both will have the same slope, same gradients. This line will have the same gradient as this line. It's just that this line's gradient will be negative. Basically, it means the height and this distance, these two will be equal. This is equal to this. Time will be equal. So the amount of time taken to reach from 0 to maximum speed, same time is taken to reach from maximum speed, back to zero speed. Let's see the exercise 12.21.8. Study this speed time graph. What is the speed at 9? 9, the speed is 0. 9:30, the speed is 3 kilometer per hour. 10 o'clock, the speed is 8 kilometer per hour. 10:40, 10, 30, 40, 50, yeah, 40, 10:40, the speed is 2 kilometer per hour. Describe what is happening from 10 to 10:30. From 10 to 10:30, uh, 10 o'clock, from 10 to 10:20, uh, the speed is constant from 10 to 20, 10:20. At 10:20, the brakes are applied and the speed is falling down till 10:30. This is what is happening from 10 to 10:30. Next question. What is the distance traveled from 9:15 to 9:30? Let's solve this now. 9:15 is here, 9:30 is here. This is the graph from 9:15 to 9:30. Just find out the area of this rectangle. This is 15 minutes and this is 3 kilometer per hour. So 3 kilometer per hour. The area of a right angle triangle, not rectangle, sorry, right angle triangle is half into base into height. This is equal to half into base is 15 meter, but it has to be in hours because this is in hours, upon 60 into this speed is 3 kilometer per hour. So this is equal to half into 1 by 4 into 3, which is equal to 3 by 8, which is equal to 0.375 meter. No, this is 0.375 kilometer is the distance traveled. Distance traveled from 10:20 to 10:30. Let's see this. 10:20 is here, 10:30 is here. The distance traveled again the same. This half into base into height. This is 10 minutes and this will be 6. So half into 10 upon 60 into 6. That is equal to half kilometer, 0.5 kilometer is equal to the distance. So that is how you can calculate the distance as well. The same you can do for further. Let's see if there is any other kind of numerical here. Just same and leave it to the students to solve. Calculate acceleration, acceleration. Yeah. So this is what is with kinematic graph. I hope you understand this. I think this is very easy. A part of this is there in physics as well. So that should be helping your cause because you're done this in motion. So this should be sorted. If there is any doubt, please reach out. I'll help you. No problem.